This is the 13th video in my series on using Google Sheets to do inferential statistics by simulation, and the 5th in this little mini-series on categorical data. We took the July 2018 Pulse of the Nation survey from the people at Cards Against Humanity. We looked at the two variables of whether or not people agree with the statement that nobody deserves a free handout from the government and whether or not they think we should be giving handouts to small working-class towns in America's heartland. In the first few videos, we scrubbed the data. We created a two-way frequency table. We created this nifty spiffy graph with different and correct standard error bars for each one. And we ran some simulations to determine that the difference between the proportion of people who agree with the statement, the proportion of people who said yes, that we should help small towns, is 75% among those who agree we should not be giving handouts. In other words, 75% of people who agree that the government should not be giving out handouts are self-contradictory because they want to give out handouts to small towns. But almost 90% of people who disagree, people who do want handouts given out, are at least consistent and do want those handouts to go to small towns. That is a 14% difference. We found in our simulations in our last video that could not have possibly been due to random chance. We were unable to generate a 14% difference just due to random chance. Now, we're going to verify that with what's called a chi-square test that will spit out the actual p-value of the likelihood of getting a difference this big due to random chance. The first thing I want to do is create a little mock-up of this two-way frequency table over here with what we would expect the results to be if whether or not people agree or disagree with the statement and whether or not they want to help small towns in Middle America are independent. What if these actually had nothing to do with each other? What would you expect these four numbers to be, given that these numbers on the outside of the two-way frequency table, the totals, do not change? So I would expect the people who agree and said yes to simply be whatever proportion 556 out of 675 is, times the 357 people who agree. So equals, I want to do the proportion of the total number of people who said yes in general, 556 divided by 675, or in this case, E7 divided by G7, parentheses, E7 divided by G7. 82% of people said yes, we should help small towns in general. And what is that times the 357 people who agreed, which is box G5. So this number should have been 294 if these two variables had nothing to do with each other. This one, I'm just going to copy and paste that formula because I'm lazy. Put it here. But then instead of doing it times G5, which is the people who agreed, I'm going to do it times G6, which was the people who disagreed. This number should have been 261. This then is just 357 minus this number, or box G5 minus the one I just did, equals G5 minus, that would be J5, the box I just did. And this is similarly G6 minus J6 equals G6 minus J6. So that's what this table would have looked like if these had been independent, although obviously they'd get rounded off because you can't have 0.06 people if they're still alive. Now, the chi-square test, the p-value. I'm going to type equals chi, C-H-I, and it's going to come up here. Chi-square test is the one I want, chi-square test. First, I'm going to highlight the four boxes of what the actual results were, ignoring the total, comma. Then I'm going to highlight the four boxes of what I would have expected it to be. Close parentheses, enter. And I can see there is an itty-bitty tiny, way under 1% of 1% chance that this discrepancy in proportions is due to random variation in the data. It's virtually certainly due to the fact that people are at least a little bit logically consistent. Those who disagree with the statement, those who think, yes, we should be giving out handouts, are in fact more likely to agree that those handouts should go to small towns in Middle America.